Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 8 of lesson number 1, Matter in Our Surroundings. Okay, so we have already studied about matter in our surrounding in the last, you can say, 7 parts, right? So this is going to be the last part for the lesson because we are just left with a small part like how evaporation causes cooling, right? One slide on that. Then we have to discuss about the fourth and the fifth state of the state of matter. Can anyone name the fourth and fifth state of matter that we have? Yes, it's plasma, the fourth state of matter, like solid, liquid, gas. These are the three states. Apart from this, we have two different states as well, which includes the fourth state as plasma and fifth state as Bose-Einstein condensate. Okay, so these are the five different states of matter that we will be start completing with, and then we have summary and then like 9 different questions to discuss. So we are going to do this like in this part 8 of lesson matter in our surrounding. Okay, so before I proceed further, I want each one of you to please revise or please go through the notes that you have made so far. I hope everyone has started revising. So see, we have started this lesson by discussing on matter, like what exactly matter is, and then how matter has been classified. So I want each one of you to please go through it once. After this, we discussed on the physical nature of matter through an activity, and in the last class, I made sure you all know like what exactly you have to do. When I say you have to revise it, you have to look at the activity, come up with the observation, explanation, and the inference part, sorry. Okay. I hope everyone is going through this activity. After this, we discussed on like how small are these particles of matter, and we discussed that through activity 1.2 again. So as I told you that you have to tell the observation, explanation, and inference for this activity 1.2. After this, we discussed on like the characteristics of particles of matter, where we have solid, liquid, and gases which have been present. So you can see how particles are organized in solid, how they are in liquid and gases, right? After this, we discussed on this activity 1.2.1. So I want you all to please go through it once. After this we discussed on like how particles keep on moving continuously, right? But in solid, because the force of attraction in solid is very less, right, as compared to liquid and gases, the solids are not going to move continuously, they are going to be stable. Whereas in case of liquid and gases, the particles will keep on moving continuously. Okay, so we have explained this again with an activity of incense stick. So I want you all to please go through it once. Then we discussed on this 1.4 activity, and I want you all to please go through it. Here we have actually studied how exactly the particles move, right? So please go through it, everyone. Then we discussed on this activity 1.5 as well. So I want you all to please go through it as well. See, I hope you all are like able to give the observation, explanation, and inference to the activities that I'm showing. That is what I want you all to do. Okay, and answer the question marks which have been given on the screen. After this, we discussed on like how exactly particles of matter attract each other, right? The force of attraction in solid is more as compared to liquid, and force of attraction in liquid is more as compared to gases, right? So we tried to study that using this activity 1.6. So now also I want you all to like give observation, explanation, and a conclusion to it. So I hope you have explained the observation and conclusion and all. After that, we discussed on this 1.7 activity. So I want each one of you to please go through it. After this, we discussed on this activity 1.8. So I want you all to please go through it once. After this, we discussed on like the states of matter, where we have discussed on properties of solid, and even we had one activity over here, right? So I want you all to please go through it once. I hope everyone is going through the properties. Like there are 6 different properties which have been given along with the diagrams representing solid, liquid and gas, right? And now after this we have even discussed on an activity which is like representing all the properties of solid. So this is what the activity is. I want you all to please go through it once. After this we discussed on the properties of liquid. So I want you all to please go through it once as well. After this we discussed on this activity 1.10. So I want each one of you to please go through this activity, like go through the you can say observation, explanation and inference for it. After this we discussed on the properties of gases. So here we have 6 different properties of gases which have been stated, and I want you all to please go through the properties one by one. After this, we discussed on this activity in detail, the syringe activity. So I want you all to please go through it once. So here we have proper explanation on the thing. So I want you all to please go through it once. After this, we discussed on like how exactly the particles in solid, liquid and gases have been arranged. So I want you all to please go through it. Go to this figure once. After this, like we discussed on, can we change the state of matter? Like, can the matter change its state? So here we discussed that water exists in three different states: solid, liquid and gases, right? So if water is in the form of ice, in that case like it is solid in state. The normal plain water that we have, it's liquid in state. And when we heat it, like it gets converted into vapor. So that water vapors are in the form of gaseous state. So this is how we can say that like there are three different states of matter which keep on changing, right? So here if you can see, there are 3 4 question marks which have been given. Now, because you're revising it for the last time, make sure you're answering that questions what they have asked, which is very important. Wherever you find out that there's a question mark, you have to see to it that you are able to answer it. That is the proper kind of revision that you will be doing. Okay. After this, we discussed on like effect of change of temperature, and the another part that we had is effect of change of pressure, right? So before we move on to effect of change of pressure, I want you to please revise this part, that is effect of change of temperature. I hope you all have like gone through the diagram properly. So after this we have discussed on different things like what exactly melting point is, boiling point is, then latent heat of fusion, latent heat of vaporization, right? So there are many things on the slide to study about. So I want you all to please go through it once. After this we discussed on like how exactly solid state changes to liquid and liquid changes to gas. So I want you all to please go through it once. I hope everyone is going through this slide as well. After this, we discussed on sublimation process with respect to ammonium chloride, or we can even take camphor. So I want you all to please go through the sublimation process in detail. And whenever you write about sublimation, make sure you are like representing the figure as well. That is very important. So after this, we discussed on effect of change of pressure in detail. So I want you all to please go through it as well. Then here we saw how the interconversion of solid, liquid and gases take place. So I want you all to please go through it once. After this interconversion, we discussed on evaporation. So I want you all to please go through this evaporation process in short. And like you don't have to go through the diagram because like you don't have much information on evaporation. Like the diagram is different, so if you skip that, it's okay. Okay. I hope every one of you are going through it. So after this evaporation part, we discussed on the factors affecting evaporation through an activity. So I want you all to please go through it once. I hope you all are going through the activity and you're doing the same thing, coming up with the observation, explanation, and conclusion for it. After this, like we discussed on what are the factors which affect the rate of evaporation and how exactly it increases, right? So I want you all to please go through it once. So now we need to study like how does evaporation cause cooling. See, in an open vessel, if you keep an open vessel, you will find out that the liquid will keep on evaporating, right? and the particles of liquid will absorb energy from the surrounding, so that they can regain the energy, because the energy has been lost. So to regain that energy, the particles of liquid are going to absorb those energy during evaporation. Okay, and this absorption of energy from the surrounding is going to make the surrounding very cold. And what happens when we are pouring some acetone, like you might have seen nail paint remover, nail polish remover. So like most of the girls, they might be knowing, but I hope boys also might be knowing it, right? So acetone is like very cold in nature. So the particles gain energy from your palm or surrounding when or surrounding and evaporate, causing the palm to feel cool. Okay, and after a hot sunny day, people sprinkle water on the roof of open ground, because the large latent heat of vaporization of the water helps to cool the hot surface. So you might have seen people doing this, like they sprinkle the water on the roof or open ground, so that whatever latent heat of vaporization is occurring, they can help it to cool the hot surface. Okay, can you cite some more examples from our daily life where we can feel the effect of cooling due to evaporation? Or why should we wear cotton clothes during summer? Now we know that we wear cotton clothes during summer because summer में जो sun है, less heat has been absorbed by light color clothes and cotton clothes, and that is why we perspire more, because of the mechanism of the body. It helps us to keep us cool. And we know that during evaporation, the particles at the surface of liquid are going to gain energy from the surrounding or from the body surface, and they're going to change them into vapor. Okay, so the heat energy over here, it is going to become equal to latent heat of vaporization. What it will become equal to? The heat energy will become equal to latent heat of vaporization, where it will be absorbed from the body and will make our body cool. So cotton, now we all have seen cotton, right? So cotton is also a good absorber. Why? Because it helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. So you can see low energy evaporating, high energy evaporating, and medium energy evaporating in the figure, right? So I want you all to please write some of the important points from here, and even like draw the figure in your book, labeling it properly. I hope everyone is writing it in your book. Now, after this, we have more to know about plasma and Bose-Einstein condensate. So, see, plasma consists of super energetic and super excited particles. So, the particles are in the form of ionized gas. How are those particles? They are in the they are in the form of ionized gases, where we have, like, you might have seen the fluorescent tubes and neon sign bulb that consist of plasma. Then inside a neon bulb, there is like neon gas, and inside a fluorescent tube, there is an helium gas. So these are all considered to be as plasma, okay? So the gas gets ionized, that it gets charged when electrical energy flow through it. So passing of electrical energy is very important over here. Okay, so this charging up creates a plasma glowing inside the tube or the bulb, and this plasma, it has a special color depending on the nature of the gas. Like the sun and the star, they glow because of the presence of plasma in them. So even the sun and the star, they have plasma in them, and the plasma is created in star because of very high temperature. Why it is created? Because of the high temperature. And the last state of matter that we have is Bose-Einstein condensate. So in 1920, Indian physicist Satyendranath Bose has done some calculation for this fifth state of matter. So based on his calculation, Albert Einstein predicted a new state of matter, and because of which, because it's a combined work of Einstein and Bose, Satyendranath Bose, that is why it has been named as Bose-Einstein condensate. Okay, so in 2001, Eric A. Cornell, Wolfgang Kettlery, and Carl Weyman of USA, they received the Nobel Prize in Physics for achieving this Bose-Einstein, like for achieving this Bose-Einstein condensate. So this has been formed by cooling the gas at low density, okay, and then about 100,000 the density of the normal air. So the temperature was very low over here, okay. So there's not much information which has been given, but whatever information has been given, I want you all to please go through it once about plasma and Bose-Einstein condensate. I hope everyone is writing about plasma and Bose-Einstein condensate, the information that has been given over here. Now after this we have summary, so I want you all to please go through the summary one by one, and then we will be like proceeding further with the exercise question as well. I hope everyone is going through this summary and you need to understand each and every sentence that has been given over here. Okay? Then we have this measurable quantities which have been given. I want each one of you to please go through the quantity, unit and the symbol that has been provided over here on screen. So after this, now we have the exercise questions to discuss. Now they have asked to convert the following temperature to Celsius state. And the first temperature that they have provided is like 293 Kelvin. And the other one is 470 Kelvin. So now I want you all to tell me like how are you going to do. So you know that 0 degree Celsius is equal to 273 Kelvin, right? So what you will do, 293 minus 273 and 470 minus 273, because you're converting it into Celsius, right? So you have to just do it like 293 minus 273. Okay, whatever answer you get, now here the answer is 20. So it will become 20 degrees Celsius. Same way for 470 minus 273. The answer will be 197 degrees Celsius. Okay. So this is how you need to do. Degree Celsius. Okay. Then second one is you need to convert to Kelvin scale. Okay. And the first one is like you will be, what you did over here, you did subtraction over here. Here you will just add it. So it will become 25 plus 273. Okay. And the answer will be 298 Kelvin. Got it? Same way for 373 plus 273. So here the answer will be 646 Kelvin. Got it, everyone? Then the third question is, give reason for the following observation. Naphthalene ball disappear with time without leaving any solid. So we know that at room temperature, naphthalene's ball undergoes sublimation. Now we have studied sublimation with respect to ammonium chloride, right, or camphor. So this naphthalene ball also undergo sublimation, wherein they directly get converted from solid to gaseous state without having to undergo this intermediate state, that is liquid state. And that is why, because of sublimation, it doesn't like turn into liquid. Okay. Then the second question that we have is, we can get the smell of perfume sitting several meters away. This is because molecules of air, they move at a higher speed and they have high intermolecular space present between them. Okay. And we know that perfumes comprises substances that are volatile and they can spread quickly in air, right? Because they are less concentrated, and because of which like we can even smell the perfume sitting several meters away. Got the thing? Then we have fourth question. Arrange the following in increasing order of force of attraction between the particles. So we have water, sugar and oxygen. So because oxygen is a gas, it will come first. I'll just write oxygen, it's a gas. Then water, it's a liquid. And then we'll have sugar. So this is how the force of attraction will be between the particles. Got it? Then we have fifth question. What is the physical state of water at 25 degrees Celsius? We know at 25 degrees Celsius the water will be in liquid form, right? At 0 degrees Celsius, because 0 degree is a freezing point, then like both solid and liquid phases can be observed at 0 degree. Both solid and liquid, okay? Then at 100 degree, because we know that boiling point of water is 100, so both liquid and gaseous state of water can be observed at 100 degrees Celsius. Got it, everyone? Now we have the sixth question, where you need to justify by giving reason. So sorry. So see, the first question is, water at room temperature is a liquid. Now we know that water persists as a liquid at room temperature because its melting point is lower than room temperature and its boiling point is higher, right? And that is the reason a fixed volume is occupied by fixed masses of water. What I said? A fixed volume is occupied by fixed mass of water, and at room temperature water does not have any fixed shape, and that is why it can flow in the contain, it is like it flows and fits in the container shape. That is why we say that water is liquid at room temperature. Got it, everyone? Then second one is, an iron almirah is solid at room temperature. So we know that an iron almirah is rigid and is going to have a predetermined shape, right? And metals, because it's an iron thing, so metals, they have high density, so that is the reason at room temperature the iron almirah is going to be solid in nature. Okay. Then seventh question we have is, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? So we know at 273 Kelvin, ice will absorb heat energy or latent heat from the medium, and it is going to overcome fusion and transform into water. So that is why ice has greater cooling impact than water at the same temperature, because water does not absorb the excess heat from the medium. What doesn't happen? Water does not absorb the excess heat from the medium. Got it, everyone? Then eighth question is, what produces more severe burn, boiling water or steam? So we know that steam produces severe burn because it is because of the exothermic reaction that releases high amount of heat which it had consumed during vaporization process, and that is why like you will get more severe burn with the steam. Okay. Then we have this ninth one, we just have to name A, B, C, D, E and F. So A will be like, there the conversion is from solid to liquid, so we will have melting or fusion or liquefaction taking place over there. In B, it will be from liquid to gas, so there we will have evaporation or vaporization process. Okay. Then C will have gas to liquid, there we will have condensation process. Then D, liquid to solid, here we will have solidification process. Okay. E, where it's getting converted from solid to gas. Now because it is happening directly from solid to gas, it is called as sublimation process. Okay. And lastly, the gas is getting converted to solid, so here also like we will have solidification process which is going to take place. Got it, everyone? So I hope whatever we discussed in this exercise, like I was a bit quick with it because I want you all to write the answers on your own. Okay. So I hope whatever I discussed in this lesson matter in our surrounding. Now you have this group activity as well, which I want you all to demonstrate if possible along with your friends. Okay. So I hope whatever, like I just told you the answers for the exercise questions. Okay. But I don't want you all to leave it like that way. I want you all to like listen to the answers that I'm telling you, what points will be included, and then try to frame the answers on your own. That is what I want from your end. Okay. So I hope whatever we have studied in this whole lesson, matter in our surrounding, is very much clear to you all. And now this is how we are completing the lesson. We have completed the lesson as well. So make sure you all are revising it. Until now, you should be knowing each and every concept properly, because we have done revision, like we have done the revision so many times. Okay. So I'll end up the session over here, and I will be starting with a new lesson in the next part. Thank you, everyone.